Alright. There we go. The hell with the sleep schedule. Who needs that anyways? Okay. I'm probably not gonna have a lot of time to stream, so let's do something that is small but crucial. This is a pretty barren wasteland of nothing. We have to give ourselves the ability to spread around some props. Now, technically, we've already made something like this when we made the tree system, but that tree system, well, let's just say a lot of the stuff in that tree system is kind of heavily dependent on it being a tree. So we're gonna make something a bit more generic. It's gonna be a prop placer, kind of like a proton scatter type deal, but much, much simpler. And also homegrown, so we know how it works, and if it stops working, we can fix it. Okay, so let's start with a... What are we doing? We need to place things, which means we need to make sure that it's visual. And maybe so that we can edit it. Okay. Sure. Scatter tool. Let's go with prop scatter. Prop scatter tool. Whoops. I don't know what the hell I just did. Dang it. Good start. It is unbelievably hot today. And this is pretty much the middle of the night. Okay. Scripts. This is dev, I suppose. Beautiful. Let's save it up. Objects. Dev, I suppose. Sure. Okay. So first things first, we need to be able to do something. We need to be able to place prop scatter tool. We need to be able to place it in level, and we also need to be able to select how big it is. So I guess what we can do is we can make it a child, have a child of a collision shape. Or, we know that it has to be a child of it has to have a collision shape. It could itself be a collision shape, but we also know that it has to be a collidable object if we choose for it to be so. So maybe change it to a static body. Because then at least it can act as a collider if we place large enough props that have colliders on them. So the collision shape in that case, well, that might not really work, because then the collision shape acts as a static element. Okay, that's fine. Now, I have technically done this in Sublinaris, and I think Child of Ether. But the reason why I'm treading this from the beginning is to make sure that I can consciously recreate the system, and, you know, you learn through repetition, so we're just doing it from scratch. So yeah, let's make sure it's a Node 3D. That's fine. Let's give it a static body. This is for collisions. Now, if there are no collisions enabled, we're gonna queue-free this node. That's good. And then also, it's gonna be another node 3D, which is gonna be the child of props. This is where we place the actual props. As a matter of fact, this is supposed to be a multi-mesh, right? Multi-mesh instance. Because these are for static props. So multi-mesh instance seems to be the best course of action. Which means we don't actually need props. And this is pretty much all that we got to do. Okay, now, when we drag and drop this into the level, we need to have it create a new multi-mesh resource, so we guarantee to never accidentally create multiple of them. Maybe? Let's see here. Okay. Or maybe it's not such a big deal. Is it? Yeah, you know what? Let's make it create one. Sure. We're gonna lazy ass our way into it. Tree entered. So when this node enters a tree, if multi-mesh, what is this property? Oh yes, that's right. Multi-mesh instance 3D is what we want to work. Wi-Fi is acting up. Oh no. That's its hint that you need to take a break, take a rest. Okay, multi-mesh. How's it going? Well, I guess I know how it's going. You just told me how it's going. Multi-mesh. So we're gonna say if the multi-mesh is null, we're gonna create a new multi-mesh and then just populate that sucker directly in here. Okay. So that's gonna save us some trouble. So if I do this, place one in. Damn it. Method not found. Defer method static body. Did I save the script? Isn't it 1 a.m.? Yes, it is. But I haven't done shit today, and I want to make some progress. So we're powering through it. Okay, on tree entered. Let's see if this works. Print. Oh, right. I'm an idiota. That's how you can tell that it's 1 in the morning, because I'm making dumb mistakes like this. This isn't going to run in the editor unless we turn this into a tool script. Anyways. Bam. And then, yeah, you can see a multi-mesh has been populated. I also want to make sure that it sets up at least a basic collision shape. And this collision shape is not going to be in the static body. This is the scatter boundary. We don't want to populate a shape into here. We don't want to populate it here because it's going to... It's not going to be editable. Ah, man. I would very quite much like to be able to adjust the shape using the points instead of the elements there. Which kind of tells me that maybe the shape should be the top node. Make scene root. And then the static body is here. Yep. And then the multi-mesh node is here. So much Hungarian in that idiota. Interesting. I've learned a bit of Hungarian today. Okay, if it's like this, then when we place the prop scatter, it can have a shape that is populated into it right away. And then we can adjust it like this, which is kind of the whole point. Okay, but what about the multi-mesh then? Well, okay. If we need to handle the multi-mesh, place the script on the top node, disconnect it from here. We're going to give ourselves an export variable called multi-mesh. mesh. And it's going to be of type multi-mesh. And then, yes, multi-mesh redefined. Oh, this is collision shape 3D. Okay, and then it's gonna basically populate it as well. So when we go back here, there's the shape, there's the multi-mesh. Now the multi-mesh hasn't been populated. Let's drag and drop. Still not populated. And the shape should probably be created as well. Ah, right. We did replace which node is the one that runs our script. So let's make sure the topmost node does tree entered. Okay. And since we're here, we might as well also set the collision shape. Let's do a sphere for starters. So we're gonna do shape equals. Actually, we do if shape is null, then shape is gonna be, what is it? Sphere shape. Make a new one, and it immediately gets populated into the shape, and then that means the shape is no longer null. So when we load the level, it shouldn't override it. Okay. So let's try this. Prop scatter tool. There we go. And then we can adjust that. And then if we need, there's another one. And that it has an independent shape. Beautiful. All right. Now, we do have the next problem. And it's the fact that we need to supply the multi-mesh. No, actually we don't, because it's already set to allow us to edit all of these properties. But this multi-mesh is a part of the collision shape. We need to also make it a part of the child node, the multi-mesh instance. So that we can do here. Okay, so both of them share the same resource. So when we edit one, it edits the other. We do need to make the multi-mesh type, or whatever the heck the actual property is. Let's see. Transform format is 3D. Okay. I don't think anything else needs to be edited in code here. Okay. Go back here. Scatter boundary. Okay, so topmost node has to be called scatter tool. And this is multi-mesh instance 3D. Nice. Goes back to the default name if you leave it as an empty. Oh god. I've managed to acquire myself a used Logitech G920 racing wheel, and I've discovered that there's actually a mod for GTA 5 that basically turns off the assisted simpleton driving and then implements realistic driving features like you do gear shifting, If you downshift too fast, you end up grinding your gears, and that could break the engine. If you start the car already in first gear, it's gonna stall. And then realistic steering, and there's actual motors in the steering wheel. So when you, let's say, go off a ramp, your wheels are no longer touching the ground, so the wheel just like freely spins. But as soon as the car lands and the wheels touch the tarmac, you can feel the force where the wheels are trying to turn. You got to battle it out and try to feel it. Do you know how many times I crashed just by trying to do a U-turn? Man, like that, it's like turning the driving parts up to 11. It's hella fun. I'm not going to lie. Especially when you gotta like hold the steering wheel with one hand and then use the mouse to shoot out the window with another. It's very tricky. But it's the funniest shit when I'm trying to like drive and I look like an old grandma with vision minus 20/20. Um, it's sounds cool. It is cool. It's very cool. Um, it just like adds this level of realism to the game. The only problem is that the mod hasn't been updated to the latest version, and Rockstar apparently did something that broke a whole bunch of mods. So you have to like download the version off of Steam. Then you have to launch Steam in console mode so that you can download an older depot of the game. And then you have to take the files out of the downloaded older depot, move them to the current game folder, replace everything, and then you basically you're playing a version that is still compatible with the mod. And I lost all my saves because of that, but hey, that's fine. It's time to play the first 10% of GTA 5 and then abandon it for another year, one more time. Okay, so we got Mesh Instance 3D. Technically, that should work. Let's take a look. So I'm gonna drop this here. Prop. We'll go multi-mesh. It's already set to 3D. And then I know that we have a boulder that Dimitar had put together. Static. No, we want to turn the material. Okay, export. I'm gonna export this to, what is it? Oh God. Custom materials. Let's make a folder code. Substance. And then this is, I don't think we need to make a folder because this is just gonna be one material. Generate mat. There's no height. That's good. And now, if I move the OBJ here, and then set instance to 1, I see diddly. Custom data, no. Okay. And then once we're here, this is the tricky part. We actually have to make the boulder unique before we can assign a resource here. Boulder on 1 T-res. Oh, he already made a material for us. Whoops. Okay. Is that the boulder? Okay. Let's see. Well, let's see. So we need to detect when this number changes. Instance count. Var old instance count 0 if engine is editor hint. So if this is taking place in the editor, then we're going to talk to the multi-mesh. If multi-mesh instance count does not match old instance count, it shall be updated. And this basically means that generation has to take place. Generate props. So we're going to call this function. And this is where the fun begins. So we need to place a whole bunch of instances. So we'll do for x inst in multi-mesh instance count. Okay. And we need to pick a random position based around the shape that we're using. So if the shape is sphere shape 3D, because we can also do rectangles, and I'd like to have the ability to do that. If the shape is sphere shape 3D, then we need to get the radius of the shape. But we might as well get the radius and incorporate it directly into the algorithm. So what do? We need to pick global position plus vector 2, vector 3 technically because we're in 3D, but we're not going to do anything on the y-axis for the time being. So vector 3, sine, we need a random angle and a random distance. The angles have to match for the x and z locations, so I guess we do rand angle. And then I think we can just do rand range from 0 to pi times 2, because we're going to be working in radians. That's random angle supplied here. And then cosine. Well, I think it's reverse, actually. Cosine and then sine. And then for the y-axis, we're just going to keep it at 0. Or, yeah, 0 is fine. Okay, now that's only the angle. Now we need a distance. Rand dist. Rand I range? Sure. No, we're in 3D. An integer distance is pretty large. Rand f range. And then it's going to be anywhere between 0, and we're going to take the shape radius, sphere shape, right? Yeah, radius. Literally the only property here. Cool. And then this will be multiplied by the sine and cosine. So now we have our position of where we would like to place it. Actually, we're actually working in local space. We might want to not add global position to here. So var prop position, and then we are going to talk to the multi-mesh, and then we know that the multi-mesh contains, oh boy, depreciated values. Set instance, oh wow, right, you can set the custom data of a custom color of the instance. Set instance custom data transform, right, yeah, we need the transform. Set instance transform. The instance number is whatever it is we're looping through right now. And then the transform, I think there was a trick to it, right? Just do a new one, right? New transform. And then we can do set. Oh, shut up. There we go. New on base transform. No, I guess not. I guess we just do it like this. Okay. And then set basis. Basis would be the point of origin. Location. Nope. We have translated. which takes an offset. And translated local, which is offset in local space. I guess that works for us. So that returns a translated version of the transform, so we need to push it back into its own variable, and then the prop position is by how much we're translating it. And that's basically it. All right, now this thing should do something right now. It does nothing. Now, it's not being detected as a tool script. Is it? Safe room. No, it is blue. It is blue. Okay, let's see if this actually works. Print. Instance count changed. Nope, it is detecting it. That is curious. Generate props. We don't see any errors, so it is looping through it. Maybe the shape. Ah, is. We are checking the type of class, not comparing a value directly. Okay. Hey, whoa. Okay. This is what Patrick Star in COVID looks like. Just a big ol' asterisk. It's interesting that it's always the same angle. So it's probably this. Oh, rand I range. Rand F range is what we want. Yeah, because pi is 3.14 something something. So that's like only 3 integers of choice, really. There we go. Nice. Now, I want to make it so that when I increase the size of this shape, it also detects that. Alt shape dimensions. Okay, so if shape radius does not match the old shape radius, it gets updated. And then we do the same thing. Let it generate again. Okay. Nice. Okay. So to prevent this, we want to be using a seed. So we're going to make an export variable. Start seed is going to be 0. It's a variable. Okay. And then when we generate, set seed. Aha, just seed. And then we just set it to that value. Okay. Now that is going to mean shit. Cannot convert argument 1 from 1 to nil. Ah, right. So, yeah, that's a really weird thing. When we declare a variable, set it to 0, even though it says 0, it's actually null. Pretty sure that's a bug. There we go. Okay. Say that's looking pretty good. Next logical step, random rotation. Okay, random rotation and random scale. So, let's go export var rand rotation. It's going to be vector 3. Is it going to be a vector 3? Do we want to only set up the maximum number or the minimum number as well? Let's do an array. Might as well. 0, 0, 0. I'm pretty sure these would be floats already because vector 3s contain floats. Yeah. Otherwise, it would have been vector I3 type data. There we go. That's the minimum and the maximum. That should show up now. Yeah, if we reset, there we go. Minimum and maximum. If we want to be cheeky about it, we could turn this into a dictionary, and that way we can add labels as keys. Like that. And that way it says min and max. Cool. Alright, let's go here. So we have translated local. Random rotation. Let's make a vector 3 value, which is going to be random rotation. We're going to calculate the x to be randf range between random rotation minimum x to random rotation maximum x. And then we just need to repeat x, y, z. And that gives us our random angle. And then we just have to do the same thing. Rotated local. Right. It wants an axis separately. And then angle as a single value. Okay. Vector 3. So x, y, 0, and z is 0. X is 1. And then we use this one here. And then we repeat for y and then for z. So this value determines which angle we're affecting. This is the value by how much we're affecting it. A little dopey. I'm kind of curious. Rotated scale translated. So there's no way to rotate it across the 3-axis. I guess maybe that's a way to prevent gimbal lock. Okay. Oh well. So if I do this, that does squat. If I'll set index min on base vector 3, set index 48. Right. Rand rot is already used. Start seed. Rand rotation. There we go. Alrighty. Oh, no, still messed up. 48. Min on base nil. Right. Mm-hmm. Now it only updates when we adjust the size. So once again, we need to detect when this changes. We can actually do that by assigning a set and a setter function. So the setter function waits and scans the variable until it receives changes. For the sake of visual neatness, I'm going to put this as one single line. And there we go. So now new value gets updated, and then we run generate prop function. Beautiful. Okay. Z doesn't want to do anything. Z, 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 right, Z. All right. Beautiful. Okay. Not bad. The next step would be to get random size. So, same sort of concept. Random scale. Minimum. Let's set minimum to 1, 1, 1. Maximum to 1, 1, 1. So that's the default size. Rand scale. New value. Rand scale gets the new value. And now we're good to do this. Var rand scale. Is that a duplication of... It is a duplication. Random scale. Okay, rand scale. Vector 3. Now, I believe that things are a lot simpler with scale, because we can do scaled and give it the vector 3 directly. Cool. All right. So rand scale dot x rand f range. We're gonna get random scale. We want minimum x between minimum x and maximum x, just like we did with the rotation. So we do min dot x max dot x, yeah. And then we propagate to y. And z. There we go. Get the Wi-Fi working. Double-sided tape saying it'll hold eternity. Well, that's how cold eternity was now. It fell off. Oh no. Ah, it must be that Hungarian uh, craftsmanship I've heard so much about. Okay. Oh god. So let's take trans equals trans dot scaled. I guess scaled local is perfect. And then we do rand scale. And that's basically it. So reset this. Wow, I love it. Okay. Randef XYZ, XYZ, XYZ. Random scale from min to max. It's interesting you guys have optic fiber. We're still running on the old satellite cable. Not the satellite, but the cable wire. Random scale. Why you no work? Do I have to do this? No. Fascinating. Randef range. Let's see. Print. It's probably not detecting the new value. I'd reckon that's what's happening. Nope, it is. Oh, it's working now. Cool. All right. Got it. Thanks. Appreciate it. Okay, now this brings us to the following question. Does it make sense to scale things on only one axis? Because I don't think we'll ever do that. Let's set it to 2. And if that's the case, we can just do vector 2 from 1 to 1. So it's just a single value. And then still need to detect when it is being set. So in that case, we don't need 3 of these. We could just do random scale x, that's the minimum value. Random scale y will act as a maximum value. And then random scale y is going to be random scale x. Random scale z will copy random scale x. And then we'll set it. Now that, keep it uniform. Oh yeah, we also wouldn't be able to do non-uniform scaling because collision shapes would not like when they're non-uniformly scaled. So that kind of throws the whole idea out the window. There we go. Let's say this looks pretty good. Now, because the boulders are centered, they are floating. So this is where we need to do our good old-fashioned raycast collisions to detect the y-axis. Alrighty, so detect y-axis. Collide with the floor, detect y-axis. Alright. Get world 3D. Direct space state. I sure hope this works this time. Intersect ray. We need to give it parameters. Var params physics ray query parameter 3D new. And I think we can we? Can we supply data directly into it? Create. We can create it and supply the data into it. Interesting. Isn't there a function to drop? There's a editor function, yes, but, you know, that's going to move the whole node, while we need to move the individual pieces of the multi-mesh instance, right? Page down is just going to do this. Well, complain, because apparently it can't even do so much as that. Yay. Okay, so yeah, we got to do this. We got to shoot array. Okay, origin. No such thing. All right, let's read up on this. From. That's where we're doing it. Okay, from, and then it's a parameter, I think. Where are we shooting the ray from? Well, we're actually shooting it from the global position. Global position. We need to lift it up. So lifting it up, we don't want it to be starting the ray from the middle. We want to lift it up by about this much. So lifting it up is adding to the y-axis. Can never remember. plus vector 3. So let's do, let's add 10 on the y-axis. Params 2 is identical, except we need to drop it way down. So we're actually going to be subtracting, but not 10. We're going to be subtracting, well, actually, yeah, we should be able to do that, because that's, the 2 coordinate isn't relevant to from, it's in global space, I believe. Is it in global space? Global coordinates, yes. From and to is in global coordinates. All right, what else do you want? From to, exclude, we'll worry about that later. Collision mask. Collide with bodies is true, collide with areas is false, so they're already set to the proper values. The default values are correct. So that's it. I just need to set the parameters. And then intersect ray actually returns something. Returns a dictionary. And it has collider, ray data. Let's print ray data for just a sec. How are you going to handle not spawning buildings? The buildings are going to be spawned, and they will be replacing any props that might be in the area. Now, to do that, because props are going to be static, or they will have a collision object, and essentially it's going to be one static body with, let's say, if we're spawning 70 boulders, it's going to have 70 collision shapes. Each one of those collision shape technically has a unique shape ID, and when the building is spawned and it detects that it has collided with a bunch of boulder collision shapes, it can actually retrieve the ID of the shape, and the ID of the shape should match the ID of the boulder within the mesh instance. So all I have to do then is just take that mesh instance and just like yeet it up into the sky by 1,000 meters, and it's just going to be out of sight, or down underneath the ground by the same amount. Right? We can't really delete stuff, unfortunately. Technically, we could have it save. That could actually be an option. We have it go through the list of instances, sample their transforms, save it, then in that array of transforms, we delete any indices, any value indices that were overlapping with the building, and then we tell the prop scatter tool to recreate, reposition all of the mesh instances minus however many were colliding, and then just go through the array of remaining transforms and reposition it then. Because then we don't have to do the whole malarkey with, putting props out of sight, out of mind. Could you... There's no visibility per instance as far as I know. There's a scale. We could scale it down, but that's not really... It's, if we're scaling it, we might as well just push it out of the way, right? So in that case, mesh instances are a little bit more limited. You have to do a little extra legwork to make that work, but, when you have the ability to display literally thousands of them, right, then it's a workload worth exploring. Because that's how we're going to be handling trees and foliage and props and everything in Automacon. God, I want to work on that project so bad. Okay, so physics ray query parameters 3D, parameters from to, and then we do this. Technically, that should produce something. Okay. Space state is inaccessible right now. Wait for iteration of physics process notifications. Okay, so we can't do this here. We got to do it in the physics process. So... Alright. Whatever you say. don't need to run the game. All right. Oh, it's lovely. I love it. And rotation. What happened? Physics process. That is a built-in function. Yes. But it may not... It may not work. Unless it just didn't save it. Huh. Okay. I guess physics process doesn't run in a tool script anymore. Yeah, that works. All right. You know what? The hell with the space state. It's been a pain in my rear for long enough. Raycast. There you go. Easy peasy. We'll just do the same thing. So, the hell with you. Now, the raycast is global position. It is local to this node, so we will say this. It will be set to the global position of this object plus this offset. Next. Raycast. I have a feeling this might not work as well because we're still technically running in the process function. Cast 2. Is that the property? Target position. Okay, raise destination relative to the raised cast position. Right. Target position. So this isn't in global space. This is local to the ray. So we are going to make it be... In this case, we need to -20. And... Yes. So now we do if raycast is colliding. I don't know what the hell this is. Okay, there we go. If raycast is colliding, we are going to get the transforms to be translated one more time. But the transforms... Well, we might as well do it before, when we're doing this whole thing. Proposition. Right? And we'll just say prop position on the y-axis is the raycast get collision point on the y-axis. I think that will be in global space. Alright, well, here's to hoping. In which case, this needs to be a process. Yep. Love it. Okay. What are we missing here? Oh, I think I know what we're missing. No? Really? Huh. I think it's a global and local coordinate system type issue. Let's not get rand scale. Get collision point on the y-axis. Print floor found. Uh-huh. And that's probably not going to give us anything ever, because we need to force the ray. Force raycast update. Which again may or may not actually work in a process function. Oh, okay, it's giving us something. Damn it, it's the same exact error. Space state is inaccessible right now. Wait for iteration. Iteration or physics process notification. Well. Okay. Now this is curious. Here's a physics process. Yeah. Physics process doesn't want to work in a tool script. Alright, let's look this up. Dot tool script physics process. Definitely not getting run. Process extends node. Okay, that was very useful. Tool script and the physics step. Okay, well this one wasn't even responded to. Running code in the editor. Hold on a sec. Maybe we have a signal we could use. Property list change, tree, visibility change, ready. Nope. Static body? Static body is a physics object. And yet... Huh. Okay, space state is inaccessible right now. Wait for iteration or physics process notification. All right, let's see. I think we've seen that, right? Did you disable vsync? Nope, still no answers. Okay. Let me double check the space state. Get world. Direct space state. Direct space state gives us space. Get space. Direct space state gives us this. Direct access to the world's physics, 3D space, used for querying current potential collisions. Multi-thread. Okay. Cast motion. Intersect point, intersect ray. Huh. That is very weird. What? It is working. What the heck? Okay, so can we do this? We had proof. It was working. Oh, floor found. So we are getting something. It is actually working. And it should be in the physics process, because that's the only way we can work with a raycast. And technically, we could go back to using a direct space state, but I guess maybe at this point we can get this to work first. And I think because we are positioning instances, I think the y-axis has to be in local space. So we need to take global position on the y-axis and subtract it from the final result of the collision, because the collision would probably be in global space. No? Okay. Well, part of it worked. Some of it bugged out. Let me do this. Comment that out. Let's make sure that it works just vanilla style. Aha. It does not work vanilla style. So something else is up. What is up? Instance count. Yeah, so these are times when we need to double check what's happening. Seed, scale. Ah. Space state isn't accessible right now. Interesting. Now, it seems like maybe it only works when we adjust the size of the collision shape. Because maybe adjusting the size of the collision shape is going to be forced to be updated when the physics process is done. That's curious. Okay, now, this still doesn't work. It used to work. Something broke. Okay. Fascinating. Okay, what did we change here? Let's comment this entire thing out. Random rotation, random scale, and then finally the multi-mesh sets the instance. Okay, let me try this. Prop scatter, place a new one. Okay. Multi-mesh. Get the boulder. Set it to 10. Okay, that works. Need to make it unique. Of all things, there's the boulder material. Might as well delete that one. Okay. So far, so good. Random scale, that works. Random rotation. Maybe we should work with degrees there instead of radians. Okay, and then this works. Okay, now let's bring this little nugget back. Ooh. Control K. Now, technically, that right there doesn't do anything. It doesn't affect our final position at all. So we should be able to still see this work. Now, we're going to tell it to apply to the Y position. Yes, it works. We changed literally nothing, and it works now. So, that's lovely. Okay, well, that works. The next step would be to make it update as we are going along, as we are moving. That should be a fairly simple thing to do. And I want to do something about the random rotation. I'm not a fan of the fact that I have to dive into this panel just to be able to adjust these values. I think this should just be exposed right away. Okay, var old position vector 3. Okay, so once again, same concept. If old position does not match global position, old position becomes global position, so it gets updated, and then we run generate props. Okay. Now, when we move this thing about, nothing happens. Actually, yes, nothing happens. But, oh, no, nothing happens. If old position does not match global position, print positional changed. Positional changed. Oh, yes. All right. Clear. Lore found. No, it is running. And that indicates to us that it's running because the raycast is being displayed. Okay. So fascinating. Ah, you know what? I know what might be happening. I don't think the raycast is in the proper space. Huh. We might want to have something to illustrate where the raycast is. CSG box, CSG. Sure. Okay, where's the raycast? Raycast is inside. Okay, now that's not an accurate representation of the ray, but should at least show us where it's located. Try adding from to property with the raycast. I believe we've already stepped on this rake before. I believe that was also the solution. But let me just logically come to this conclusion. We take get collision point. Returns the collision point at which the ray intersects the closest object. If hit from inside is true, the ray starts inside a collision shape. This function will return the original point of the ray. This is in global coordinate system, so it shouldn't matter that the 2 is there. It's in global space. So we have to compensate for it. Which means maybe we have to keep in mind that this has to be in local space of multi-mesh. Which technically it is what we're doing here. We're subtracting the from of the raycast is its global position. that broke that. I'm sure it's somewhere over there or something. Hmm. Okay. Just bring it back to the place where it was before. Which it doesn't want to go back to the place where it was before. That's weird. Okay, I'm just gonna humor this for a sec, except we need to redo the whole thing. Prop scatter. Okay. Boulder. Make unique. So that we can place it here. And that... Okay. So we saw the node change. I had trouble with tool scripts failing to update. Yeah, I think that's what we're experiencing here as well. Okay. Invalid index Y on base float. What are you talking about? Oh, right. Uh-huh. Okay. Right. So this is the tell that it doesn't really work. The boulders... Ah. The boulders are treated as one. That's why it looked so weird. But I don't want the boulders to be treated as one. That's why when we position, it has to be positioned not at the global position. It has to be positioned at the prop position. And the prop position is local. So we need to do global position plus prop position. Target position is relative. There we go. That's what we're looking for. Okay. Now it looks like the ray is not tall enough to reach the upper area, so let's do 20 and then minus 40. So it drops down by twice as much as we raised it up. There we go. So now the ray is performed per object. It's looking pretty good. A little weird though. Like, why is this necessary? When we ask... Oh, no, that makes sense. We have to do this because multi-mesh instance, all the instances are in local space. So we have to, and then the raycast gives us the position in global space relative to the entire level. So we have to say, whatever this gave us, take out the global position of the multi-mesh instance or this entire tool node out of it, and then this gives us the local position. Got it. Okay, so now my brain has brained, and I actually understand why this is important. Cool. All right, now let's deal with this thing. So, rand rotation minimum, which is going to be just a vector 3. Now watch us completely shag it up entirely. And then random rotation maximum. Okay, and then we go down here. max, 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 min, min, min. Beautiful. So that gives us a nice property that's just out here, and we don't have to worry about anything. Beautiful. Okay. Space state is inaccessible. Yeah, we know. There we go. It's really curious. When the values get changed here, they don't actually... They're not being updated in the place where raycasts can perform their duty. All right. Also, I find it kind of curious that vector 2 values get split up into 2 columns or 2 rows, while vector 3 values get an entire column. And yeah, or 3 columns, 1 row. Jeez, I need to get my Excel terminology right. All right, so there we go. We now have this. We can adjust the number. What's next? Well, next we need to make them collidable. Now, that is going to be optional. So we're going to go here, var make collidable false. Okay. If collidable is false, let's take a look here. New val. Collidable will propagate the value that we just changed into it. And now we technically, we could, I guess we could just run generate again and handle it there. So if collidable is true, then what do? Well, we have the collisions node, and we basically need to insert a collision shape to that node. We need to create as many collision shapes as there are props. So, for starters, we need to be able to supply that shape. So, var collision shape prop. Let's do prop collision. And then let's give it a type. Collision shape 3D. Okay. We're gonna detect when it's set. Prop collision. New value. If collidable is true, then we need to actually make the collision. Okay. We know that the boulder is non-standard shape, so we could do this. Ooh, place this here. Then make sure it transforms or reset. Then we do simplified convex collision shape. Then we delete the boulder. We get the shape. We can save this shape, save as. And let's, I guess this is going to be made somewhere here. It's like resources or something, isn't it? Resources, collision shapes, and this is boulder 01 with a capital B. All right, we don't need this. Instead, we go to the level. We populate. Didn't quite save the setting. Uh-huh. This is that fabulous failure to update the tool script comes in. That's lovely. Don't know what causes that. Okay, beautiful. Nope, it's still not here. Oh, well, it wouldn't be here because I didn't make these export variables. And as always, the failure in the engine was actually the failure of the user. There we go. So it is collidable. Now parameter DSS is null. Raycast 3D, right. Because we're setting the property here, and that causes the raycast code to recalculate, and there's nothing to recalculate. Oh, that's not good. It's looking for an assignable. That's not what we want. I think it's just shape 3D, right? Let's see. Convex polygon shape 3D. But that inherits from shape 3D, so that's what we want. Because shape 3D includes box, curve, capsule, all of these, including the convex polygon. So we want to have the freedom. So shape 3D is what we want the data type to be. Yi. Okay, we go here. Now we want one of those shapes, or we can supply our own. There we go. And it's failing to position anything. Did I muck something up? The raycast is definitely going far enough into the ground. Maybe once again I gotta reload the level. Alright, fair enough. Old Godot had a bug. Yeah, yo. Godot developers don't give a fuck. Okay, come on. You sack of sacks. Can we get this to work? Why you no work? Maybe it bugs out because we left something in here. Oh, well, there are actually errors. So that could very well be. Let's get rid of the floor found. So we can actually see what's happening. Brain needs sleep to avoid malfunction. Yes. Okay, position changed. So it did. Boulder was updated. Seed. Random rotation. Okay. OBJ is real. I'm not imagining it. Okay. What could possibly be the issue? Well, let's see. I'm going to delete this. If this actually fixes it, I think something's wrong with my code. Okay. Question is what? Yep. Alright, well that's working. And it is positioning itself all over. I think it is actually important that we don't rotate. Yeah, you can see what happens when we rotate the whole thing. There is a way to fix it. I think we just have to rotate the whole transform using the rotation of the actual node. Yeah, because otherwise this happens. The wrong boulders get adjusted. Rotated. Rotation. Hey, hey, good night. Well, that was quick. Expect at least 2 arguments. Dang it. It wants all of the arguments. Okay, I am less convinced that this would actually work. Oh. Oh. Not really. Or is it? No, it's not. Alright. That's enough of these shenanigans. Okay, we'll just make sure that we don't rotate the nodes. Okay. Now, collision shapes. Right. So we need to make it so that if it's collidable, it has to add a collision shape, one collision shape for each boulder into this collisions node. So var new shape equals collision shape 3D. Make a new one. Then new shape. We need to talk to the collisions node. Add child. Add the shape. Set the shape to be equals to whatever is the shape that we had selected here. Prop collision. Yes. And then transforms. And I think for the transforms, we could just copy paste this transform here. Maybe even it would have to be a global transform, but we'll see. The only downside is that we're not going to be able to actually see the collision shape here unless we give it an owner. Owner get parent. And I think the owner has to be set before we do add child. Before or after? Let's see. Oh, no, that's get parent. Owner. In the editor, nodes not owned by scenes are usually not displayed in the scene doc. It will not be saved. To prevent this, remember to set the owner after calling add child. After calling add child. So this was correct. Okay. I'm going to save real quick. Oh. Okay. Now this is actually very dangerous because we keep creating shapes every time this runs, but nothing is destroying them. So, remove old shapes or shape child in collisions, get children, queue free. And not only that, we also should remove child. The removing will immediately strip it out of the list, which means when the new child is added, its number, like shape 2, shape 3, shape 4, will actually begin from the beginning again. Otherwise, the numbers are just going to keep growing, even though the previous children were just deleted. So we'll remove them as well. Okay. Now, I still don't see squat, but then again, it could be that I just need to reload the level. Okay. Okay, is this going to work? No. Okay, well that's not good. If we're going to lose it every time we reload the level, that's not exactly great. And also, you know what? The parent node cannot be the owner because we actually want specifically the editor node, the level, the physical node that's in the editor, not in the game. Okay, let's see here. So I think we need to do this. What property does the owner want? It wants a node. Okay. Get edited scene root. Editor interface. Get edited scene root. And then we have scene tree. So we could do get tree dot edited scene root. Is that a property? Yeah, it is a property. All right. Oh, we should see at least the collision shapes. Oh, they wouldn't be seen. We didn't populate one. Hey, look at that. We got our shapes. And then if we do this, it causes them to rotate. You know, what if we do this? What if what if we check if the number of collision shapes is the same as the number of instances, and if it is, we don't destroy and recreate them, even though it works. Huh? Let's do this. If get child count does not match multi-mesh instance count, or collidable is set to false, because we should be able to destroy it, then it is going to go through the children and destroy them. Next, We're going to copy this code again. We go down here. If the number of children is not the same, we create the child. If it is the same, we get the child. Get child, and I think that the for loop has the variable called instance, which just simply contains a number that we can use here. New shape. Let's just make a variable here. Var shape equals null. And then here, it will simply be populated. And then here, it will be retrieved. And then any sort of edits will take place here. As a matter of fact, I don't think we have to set the owner after it's been populated. We do need to set the shape. Actually, no, even then. Shape only needs to be set. Whoops. If it's being created. If we're editing it, it should stay the same. Okay, alright. Well, there you go. Now let's take a look at the performance. Oh, yeah. Oh, yeah. Oh, that's much better. Oh, yes. Cusco. The poison to kill Cusco. Right. Okay, does this work or am I tripping? I'm tripping. Now does this function generate props on... Oh, God. You have an error? No, you don't have an error, you lying sack of stuff. You need to be reloaded. Close it. Open it. Level. Yes. Okay. Really? Really? You're gonna do this to me? Again? Oh, now it just doesn't work at all. Okay. Not only does it not work, it's also not populating the collidable, which we saw was working before. Shape is null, sets to null. If collidable is true, then do we have to do this twice? Or is the process function just not working anymore? That could always be a case. As a matter of fact, it isn't. Because we have position changed being called here. And that never pops up. So it goofed up again. Well, that's not my fault. 26th hour awake. Go get some sleep, man. Jeez. Yeah, it just doesn't want to run the process function, the physics process. After you, good sir. You're never gonna get that sleep, you hear me? You're gonna stay here awake with me. Time to get comfy. Alright. This does not seem to work. Now, I bet if I take this, drag and drop a new scatter tool. Nope, that also doesn't work. Oh, that doesn't work at all. So, this whole tool stopped working. This whole script. Is there an error? Hold on. Let's do a... Your son was scared to death. Why wasn't your son asleep? Hey, get your little butt... Alright, get your little butt to bed. Otherwise, we're gonna have to make use of the poison. You know, the poison. Cusco's poison. The poison to kill Cusco. Get your little butt in bed. Although then again, it's 8:30 in the morning. Oh, well, never mind then. Enjoy your show. Okay, let's see. Maybe it is like an engine thing and we have to restart it. I forgot that not everybody lives in Canada. Some people are actually civilized, and they live somewhere else in the world. Okay, well, we're fast approaching the 2-hour mark. I was kind of hoping I'd be done by this point. Come on! Load, you bitch! Okay. So. Nope. So that maybe is telling us the script is broken. Node has one connection. Tree entered. And yet it doesn't want to take us... Hold on. Yeah, it doesn't want to take us to the script. Process tick interval. Oh, it's slowing. No amount of delta is gonna help fix the lag, compensate for the lag happening right now. Hey kids, you ever wanted to get jet lagged without flying? Learn programming. You'll love it. Slow tick speed. Yeah, chronicle. Okay, so I've updated the script, the signal. I mean, at this point, it's... Okay, there we go. No, it still wants to be a thing. Use your imagination. Yeah, so it doesn't run anything. Is there like an error that I'm not seeing? Am I a stupid? There's no syntax error, but we all know that Godot likes to still run your project even if there's a code error, even though we're technically not running it. What's the last thing that we've added? Collision shape stuff. Let's take that out. Okay. Drop this in. Oh. Now that works. So we know where to look for the issue. It's the collision. Somehow the collision code is broken, but it's so broken that even Godot's like, go figure. You wrote it. I don't know, man. Okay, this is beyond annoying. That's gotta be an engine bug. I mean, I know I've said that too many times in this stream alone, but that's gotta be an engine bug. Are you sure you were opening the level? It didn't require to Yeah, I did it like 3 times already, but that wasn't really the problem. It started working when I commented this code out. So when I bring it now back in... Wait. The shit is this? I'm talking to shape. Shape is a built-in property of collision shape, and I'm setting it to null, but I am declaring it as a variable. Okay. Prop. Is prop shape a built-in? No, it's not. Okay. So maybe that's what the reason was. It didn't quite catch on that I was editing a built-in property. Maybe? Let's see. Well, it didn't... Oh, okay. Now does this function generate props? Now that would happen when there's an error in the code. So if I do this, comment it back out, it's gotta... Yeah, it works. Okay, so bring this back in. Let's see what's happening here. This is a new variable. If collidable is true, we check. Do we have as many children? Get child count as the multi-mesh instance has instance count. Now, if that doesn't match, we create a new shape, add it as a child, set the owner, which worked. We saw that work before. Set the shape to prop collision, which is up here. And then we set the transform. Otherwise, if the number of collision shapes already matches, we don't need to do the owner thing. Oh, I'm just overriding a variable here, which makes sense. All we're doing is just getting the child by this number and then try to set its transforms. Maybe the shape is just needs to be set in both cases. What would have happened if you didn't remember the last change you did? I'd be jolly well something. Watch George Carlin for the ending of that sentence. Okay, that works. Now, collidable? Yes. Huh. Fascinating. So, I suppose the shape has to be set in both cases. Just in cases. The owner... Maybe? I guess it won't harm if we do that. Alright. There we go. Yeah, and then you can see, even though that did take us a little extra longer than usual, that is a lot faster than when we're deleting and recreating the nodes. I think if I do this now... Oh, what the heck? Why did it just do a kickflip? We need a God, I need to get myself a soundboard. It would be a... Yeah, what the What is that? Okay. Maybe it's just momentary graphics glitch. What? I think it is. Either I keep skipping it, or it just self-corrects. Okay, well, I mean, it works. There you go. So we can now place boulders rocks, and they should have... Whoa! Right. They're self-colliding. Okay, so this is where we need to add the... Oh, yeah, nice. Okay, we could just add this the static body to the exceptions. Raycast, which we only need to do once here. Raycast, add exception, collisions. That looked pretty, not gonna lie, but we don't want it. Okay. And that's only gonna work in the ready function, which we should probably do that not in the ready, because that only works when we run the game. We need to do this on tree entered. Okay. Now, of course, that's going to make it not work unless I cut it out. Paste it back in. Nice. Okay, so now the raycasts are not colliding with the very things that it's placing. Let's give it a test. I think maybe an offset, a Y offset property might be a nice thing to add. Okay. Did it crash? I think it crashed. Prop shape owner. Get tree. If engine is editor hint is false, we return. We don't want running this in the game. We want to run this in the editor. I think there is a particular problem when you load up a level. It causes all of the export variables to be defined with whatever value you set them, which causes the pickup script, the detection script, to kick in, and it ends up regenerating everything. Okay, are we crashing again? No, we're just loading a really long level. There we go. Boulders? No. There's quite literally nothing. Why is there nothing? They're here. And the boulders have been added. I think I remember playing around with some sort of a multi-mesh placement tool, and there was an explicit button that said commit, and it had created actual nodes, physical nodes, to, I guess, solidify your choices. We're working with the multi-mesh here, and we've done this before. We've done this with trees. Okay, it doesn't really detect when the seed gets changed. Might wanna change that. Start seed. Set new val. Start seed gets set to the new value, and then we run generate props. Right, which should be okay. Set the owner on the, depending on the editor hint, but that means the whole script is going to run twice. I get what you're saying. The scene that's in the level is not the same as the scene that's in the editor. So the owners would have to be different. Okay. Let's see. Actually, I think I might... do I know what's wrong? If I do make editable children, we can actually see all of the shapes physically populated here. What if I run with visible collision shapes? Should we see the shapes? I think I already tried walking into the boulders. Didn't see nothing. Come on. Don't make me wait. Unless you crashed. Nope. What? 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 Nah. Really? Nah. I literally didn't do anything. Except what? Visible collision shapes? I did move the thing, which would have caused it to regenerate. Son of a gun. Come on. Give me the main level. Etse så ribok och så Nike. Okay, well they're there. We can collide with them. I guess... No. No. You know what I did? I made it editable children. So, if we do it like this... that makes it not be exposed in the main level. Dang it. I've seen how quickly this game loads on Cole's computer. I think I might want to consider upgrading mine. This ancient potato is I don't think this is even like an average computer at this point. Can you do that in code? I can create the collision shape node in code. Yeah, look at that. Look at this shit. Okay. So. Unless we let it run in both the engine and the game. Dang it. Okay, well, no, that went belly up. Right, we had to place that because the owner was incorrect. Which might... This is shape. We saw that the shape does get set correctly. Okay. I suppose if editor is... Whoops. Engine is... editor hint. If it's in the editor, then we set the owner here. See, this is what I want to avoid doing. I want to avoid having to run this code twice. If it ran once in the level editor and placed all the shapes and placed all the multi-mesh instance values, there's zero reason why it has to run again in the level. That's kind of the whole point of doing it in the editor, is that you do it in the editor. So the game doesn't have to do it. Because that's extra performance. Dang it. Now it's just entirely gone. Oh, no, we still see the ray over there. Oh, okay. I guess maybe it didn't generate because literally nothing here actually called it. Let's do it here. We're gonna say as soon as it enters the tree, we're gonna run it. I'm running the wrong scene. Okay. Okay. Dang it. What are we doing wrong? Okay, let's assume that we want to make the processing be done in the editor. So these parts should be okay. In which case, collisions node should exist as a child of this node, but not in here. Okay, so when we add var, or I guess we can just do, yeah, no, we need to do static body equals static body 3D, make a new, and then static, we do add child static body. We say static body dot name is going to be set to collisions because we already talked to this node all over the place. That's for collisions. And we need to set the owner. I think we need to do same thing we did here. Okay, this will make it physically appear in the editor. And if it's physically in the editor, then it physically exists as a legitimate node. Okay. Okay. Now that is because we need to get the exception code. Where's the exception code? It's over here. And the exceptions would have to be done here. Which we can just feed the variable with the node we've just created inside. I don't need to run the game. Get back down. Come on. I think with my monotone voice, Zoltan's kids are going to go into nap time number 2. That's why he lets them watch it. Okay. Add exception. Oh, right. It's already in the tree. So we need to cut it out. Paste it back in. And that's literally did nothing. It did give us errors. Let me try this. Cut it out. Paste it back in. Interesting. Add exceptions. Static body. Yeah, I do see the collisions node, so it did appear. It appeared multiple times. We may want to double check that. Because, yeah, the original one was there, so it wouldn't really do this. That's why we have to do collisions. And then before creating a new one, just for the sake of our safety, if has node collisions is false or not Then we let it create the node and set the name and the owner and all that good jazz. And then it's going to add it as exceptions. Okay, technically, we don't really have to do that, because once we place a new node, it's just going to be placed right away. It still doesn't want to work, because we still managed somehow with 2 collision nodes. Okay, cut it out, paste it in. Okay, now it's just messing with me. I think this is where I need to close and reopen the scene. This is building a Lego death machine. Ah, yes. Sounds like pretty standard issue Hungarian kid stuff. Papa, Papa, I built a death machine. Not again, son. You know what happened last time. The man in trench coat come in. Your daddy cannot go to Gulag again. How many times? How many times must you betray me? My own flesh and blood. Okay. I'm losing my mind. That works. Okay. Can we see the mesh? Please? Right, so for the mesh, right. The mesh. Mesh, multi-mesh. Yeah, so I think we're gonna have to do the same thing. We cannot have the multi-mesh instance being a child here. We need to go here, var, multi-mesh node, new, add child, multi-mesh node. Watch all of this work and it's still not going to show up in the game. Multi-mesh node, and then multi-mesh node owner. It's going to be set here, although I don't think that would make sense logically. If not has node multi-mesh instance 3D, it shall create one. Okay. And the reason why we do that is so that we would still have the ability to cut out and paste it in. The name of the node is not quite right. That's because when we add child, it might be a force readable name. True. And then we got to do the same thing here for the collisions. That's why it kept creating, recreating the collisions node. Okay, so you just go away. That's fine. Let's just place a new one. Although might have been wise to identify why that wasn't gonna quite pan out. The funny thing is that now that we've done that, we didn't really need an export variable for the multi-mesh. But I guess here we are. Set it to 10. Boulder. Schmolder. Agent Schmolder. Do you believe? The aliens are out there, Scully. I can feel them in the walls. Make unique. Now, we can place the shape here. Okay, there's 10 of them. Yes. A radius. Yes. Interesting. That might be a problem. Every time we adjust one of these values, it ends up doing this. Now, actually, it doesn't like line 213, which is non-existent, so that's lovely. Raycast 3D C++ file. Inaccessible right now. Space state. Huh. Is there any way to check if the space state even exists? if it's accessible. Because this is a bit of a problem. Every time we adjust the scale, it ends up recreating the elements. But because when these are changed, I think I know what we can do. Instead of having all of these generate props functions run right away, we're going to make a variable updated. Set it to false. And then this is going to be set to true. We're going to replace carefully. Okay, that's going to set updated to true. Then in the physics process function, if updated and it's an editor hint, it will run let this stuff run. So that way we guarantee that every time we update the values at the top, they cause the regeneration to take place in the physics process. Okay, so that works. And that works, except maybe the code hasn't been updated. Come on now. All right. Translate. Now it's just broken. Ah, yes. As I had planned. Oh. I would put a hamper in my process. Come on, really? Oh yeah, there was a space in the beginning of the replace. Whoops. And what do we have here? Shape was set. I guess we can do it here. And you know what? Sometimes I find myself wanting to update it, but I have to nudge it in order to update. So let's make another export variable. Update. False. And then we're going to give it set new val. We will not be populating the new value so that it's perpetually false, but it will detect if the new value has been updated. And then we're going to say updated true. And that should force it to update. If there are no more errors in the code, that is. Save it up. Now that looks broken as stuff. Oh, hold on a second. If it's true, it has to be set to false. Otherwise, it's just going to be perpetually running non-stop. Okay, let me try this. I gotta say, I feel like I've gone one ginormous roundabout with this whole placing nodes as child so they physically appear here. If it works, I'm gonna be glad. But that seems like a huge, unnecessary chunk of work. Okay, there's the thing. It doesn't detect this anymore. Really? Is that like a built-in property? No, that's just referencing my script, my tool script. Updated is false. Here we set it to true, which, to be fair, it does actually make it run. It's just that all the other update functions cease to work. Really? Like it works, but it doesn't. Set random scale. Oh, that just... No. The shapes were created. They're just not being updated. Now, okay, to be fair, this works. But that has introduced like an entirely new issue. For some reason, I can't update this. Updated. Okay, let's try changed. I don't know, just a hint. Nope. It is updating if I press the update button. Wait a minute. Those properties don't get updated this way. Excuse me. Hold on a second. If this is the editor, if the instance count has changed, then it runs this. That is okay to run it here because we're already in the physics process. This is okay. This is okay. And then we can do if changed is true, changed becomes false, and then we run the generate props. So we don't need to do it here. Actually, yeah, that's good. Okay. I don't need to run this. Why am I running this? Stop it. Get some help. Why am I running it again? Stop. Switch to 3D. Okay, so now it's updating it. Right, so the issue was we didn't actually have to use the update variable on every property. Some of the properties are already being checked in the physics process. Okay. Rotation, scale, so the smallest scale. Oh, we can do inside out. Oh, that's funny. That's fine, though. Okay. Okay, and then to set the material, make unique. I honestly still don't know why we have to make it unique. Here we go. All right, now, moment of truth. All of this is going to be useless if I run the level right now and none of it actually appears. Okay. Let's see. 2.5 damn hours. Yes, they are here. The boulders are here. Nice. Some of them mesh into one another too. Alright, we have collisions. So that worked. Now what I'm half tempted to do here is to copy that script and then make an alternate version of that to see if I can get it to work without having to instance those nodes as direct children. But I suppose for that to work, we would have had to make it be... Yeah, we'd probably have to make it run within the level. Okay. Now we don't need the raycast visualizer. Get rid of that. We know it works. And now... That's good. So ultimately, I can do another scatter, prop scatter tool. I can populate, I think we have a tree. Tree mushroom. Okay, right. Let me double check. Pretty sure Dimitar had made some rotten hollow trees that we can use. Okay. Let's see here. Yep. So what is this? Let's do the stump. Okay, so stump, tree stump all one. That's what we're looking at. Okay, we'll do 6. Random rotation. Okay, random scale. Nice. Okay, is the detail... Does the detail layer actually have the data? All right. No, we are in detail painting mode. Ah, there used to be a detail layer there. I suppose it was lost. Texture. There we go. Now we got grass. It even has shadows. That's nice. We can adjust the density. So I would imagine this is also multi-mesh instance based. Okay. Custom shader. If we wanted to have grass that's always facing the camera, but I don't think that's really a wise way to do it. Shader parameters, instance scale. Okay. Ambient occlusion. So it gets darker by the bottom. Bottom tint, top tint, cast shadow. Instance mesh. Uh-huh. So if it's a non-standard mesh, it looks like, yeah, so it's just a flat plane. All right. That's cool. Albeit everything is just the same exact height. Would be nice if we could adjust it. Like randomize it. Layer index 0. And then the terrain has some interesting features like wind simulation. Thanks to the terrain system. Map scale. LOD, yeah. So this would be in the terrain details layer. And yeah, it looks like we can't really do scale. It's a Node 3D node. Interesting. I would kind of expect it to be multi-mesh instance. Maybe it is. Yeah, I think it is a multi-mesh. Yep, there we go. All right, fair enough. Now, the interesting thing is that with this whole multi-mesh system, if we make, within the multi-mesh node, if we make the mesh unique, we can override all of the surface materials, which means we are able to use complex models that have multiple materials assigned to them as a part of our multi-mesh node. And I've had this issue before when I was trying to figure this out. The issue was that... Whoa, that is really shiny. The issue was that I assumed that the multi-mesh instance was limited to only having one single texture. There was no way for it to do like multiple textures. Oh, okay. Maybe density could be toned down a bit. View distance. Okay, yeah, so this is something we'd have to adjust. That is a really weird reflection. Also, curiously enough, I don't see the shadow as well. Okay. This looks cool. Maybe I have to move the flashlight a little bit further to the right. It sounds like my movement code is no longer... Wow, that is a really, really far-shooting flashlight. Like, you don't have to be afraid of anything with this bitch. Dang. I'm gonna need to tone this down. Now, I don't remember doing this, actually. This must be Antoine's handiwork. Maybe. I'm not sure why that happens. But okay. Well, okay. I think that's enough for today. We made our asset placement. It works. Oh, that's really goofy. I have a feeling that the method we employed here for placing all these props physically as nodes might actually contribute to the load times of the level. So maybe we do want to do the old system where we let the code run in the editor and we also let it run in the game, and any extra performance implications of having it run in the game is just contributed to loading screen. We're loading the game. I think that's fair enough. It's like my flashlight just died. Also, this looks pretty nice for nighttime. I didn't really want it to be pitch black, because we've seen plenty of games that do that, including some of mine. And the night being pitch black is not exactly fun when your entire vision is just limited to this tiny, tiny little circle in the middle of the screen. That's not really fun. Now, we could have blackout periods. I don't think that's such a bad thing to implement, where you actually have to use the flashlight, but we want to make those rare, not a normal occurrence. There we go. Oh, this doesn't work anymore. Alright, that's fine. We'll sort it out. Cool. Okay, that's it. I think we've made good progress. We now have an asset placement tool. We're going to continue this in the next one. And thanks for watching.